All right, students, wanted to let you know how to use Vericut with Fusion, and it turns out that it's really easy, so it's worthwhile. Okay, so I have my model here that I created, and I feel pretty good about my toolpaths, at least as far as Fusion is concerned, so I would like to use Vericut to check this. So what I'm going to do is go to the Setup, and I'm going to right-click on Setup, and I'm going to go to Post Process, just like we've done previously. Now, when I go to post process, I have to choose a machine. Yours will probably come up with the Haas Mini Mill, but anyway, you can choose some machine. Make sure that you have the correct post processor chosen, which needs to be this WWU processor. Don't just choose the other PNGC one, or it won't have the Dell pin coming down. Now, the big difference between the way that we've done it previously and the way that we're going to do it this time is we need to have this button right here clicked, this Use Cascading Post. And when you click that, it will come up with another entry box here, and yours probably won't say anything. When you open the folder, it's going to take you to the post processors that are cached on your machine. So if you're going to have to be logged, or at least VPN'd to campus to be able to do this. Should have said that earlier, sorry about that. Okay, so we scroll down here, and way down in the list, we'll see that there is Vericut. So let me get down there. UV. All right, so right there. So vericut.cps is what we need. If you don't have this post processor, you can search Fusion post processors, and you can go get it and save it somewhere. Anyway, I'm going to open that. And then this is sort of just the way that I normally do things. I need a name for it, or a program name, and then I need a comment. So I'm going to make this be Gil Chevron. And then I need an output folder. So I'm going to go select an output folder, or then go to labs, and then go to the Chevron lab, and I'm going to select that folder. Great. You could post it to the team if you wanted to. You would have to make sure it goes to your folder in the team. I don't know exactly how that would work. So we're going to use the units that are in the document, and then some other things over here on the right side. I'm going to make mine start with go by in increments of 1 for the line numbers, because we have so many line numbers in these big programs. And then this is going to start on 10, but it doesn't really matter. And I'm going to use those numbers. A couple other things down here. The tool, or is the preload tool, I have that turned off because I don't want it to preload that tool. So I'm going to turn that off, and then everything else looks okay. Down here in the built-in, you could do something like preserve single axis rapid movement. So if it was just moving in X, just moving in Y, or just moving in Z, it would do a rapid. That would actually make it go faster. I would be hesitant to use preserve rapid movement. I would think that single axis rapid movement would be fine. You could also do just axial, or you could do high feed. The good part of this is that it might cause it to do rapids across the part, which would make it a little bit faster. So I'm going to choose preserve single axis rapid. It's going to do 500 otherwise. So I'm going to hit the post process button, and it's going to bring up a Vericut window. And this Vericut window will probably be blank for you. Now, this part is pretty important. This installation path, turns out, is just that you're telling it which version of Vericut to use. And so you want to go to your directories, and I'm going to go to this PC. I'm going to go down to Windows C:, going to go to Program Files. CG Tech is the name of the company that makes it, and then choose the newest version of Vericut, and that's the folder that I picked. So it's just asking, do I want to use version 7.2 or 9.2? I want to use 9.2. you may have more or fewer versions on whatever computer you're on or can get a hold of. So I'm going to hit OK. And then here for the Vericut machines path, what I want to do is hit Browse. This is where it's going to find the template. And so I want to go to in : on the machine. So I'm going to do this PC. I'm going to go down to Engineering Shared. Right now we'll go to Student Resources. And currently all of these things are under Manufacturing Engineering and then ET136. So that is the lab space. When I get down here, there's this new folder called HSM Fusion Resources. So I'm going to choose HSM Fusion Resources. So HSM Works is just the version of Fusion that we will be using on SolidWorks in the future. And then Process Templates, and then HOSVF2. I don't have a mini mill process template in here right now. It's a little bit broken, so I have to fix it. But anyway, it doesn't matter much what you choose, and in fact, this doesn't exactly have to match the machine previously. The only place that this would come into account is the VF2s do have a higher feed rate capability and a higher spindle speed capability than the mini mills, so that would be a difference. And then just the envelope or the size of the volume for the axes. So I'm going to hit OK there. It will show me any machines that are available, and I can select them right now in that folder. The only one is this VF2 Process Template 1, and I can skip the base tool number and hit Accept. And when I do that, it is over on the other side. It brings up Visual Studio Code for me. May bring up your code somewhere else, and then it will bring up this window, which is slightly shifted. There we go. So it brought up this this Vericut window. There are a couple things that are a little confusing. One is it brings up two coordinate systems, and you can see here that the coordinate systems are any one that is not grayed out is displayed. But what's important is here in the G-code offsets. So if I single click on G-code offsets, it tells me what the G-code offset is. So when I do a G54 in my code, what does it tell Vericut to do? Well, it says to take the spindle, this component origin spindle, and place it at the coordinate system origin program 0, which is on the upper right rear almost of this part, so I can see it right there. So that means that the program 0 is the one that matters. If the other one confuses you, you can single click it and then right click and go to display, and if you do that, it'll at least turn it off. A couple other things to note as we're about to run this is that the model for the part is turned off right now. If I click it, if I go to visible, it will turn on. Notice it is only here in the machine view. I suggest that you leave it in the machine view, but not in the workpiece view. Remember, if you have the part turned on and you machine way through the stock, then it will show the part rather than showing the errors that you made. And so when I do this, I use the machine view to be able to see tool changes and things like that, to see how the part is moving around. And I use the workpiece view over here to make sure that the machining went correctly. The way that that's done is here in visibility for the design. So if I click on design and then go to visibility, you can see that I have it set for machine view, but not for workpiece view. So if I wanted it there too, I'd do both views. When we go look at the stock, you'll see that I have the stock visibility in both views, so I can see it. And now all I have to do is reset and run. And I'll increase the speed some just because I've already watched this code run, so I know that it's good. You should watch yours a whole lot slower to make sure that it works correctly. All right. So there it goes, and it finishes all the machining. So now I want to know if it's good or not. So remember, there are a couple different things that I can do. One is to go to info and I can hit status and choose status 1 or status 2. Status 1 is a little bit more meaningful. And I can use that to see all the XYZ positions. I can see that the total machining time is 50 minutes and it has 34 minutes of air time as it's moving around. And then I can see the amount of material removed and things like that. If I were running it, I could see exactly where it is and what speed it's moving. But then also remember I can do the analysis. So I'm going to come over to analysis and go to auto diff. And I'm going to choose a much smaller number than this. I'm going to choose 1/1000 for the first time through for my gouge and my extra material. I'm going to hit apply and then compare. And when I do that, you see that I'm left with this blue area, which is excess material. Now, you can't see this, but what I do is I put my finger on that blue material so I can tell exactly where it is, and then I hit the restore button down here. And when I restore the model, what I'll see is that that blue is right down here at the base of the chevron, all the way around. And in fact, if I look at the part over here in the machine window and then reset it, remember we're watching for that base. And when I look at, oops, it moved. There we go. I'm going to close the auto diff window for a minute. If I were to turn off the stock, well, I'll take the visibility to invisible for a moment. Notice that at the base of the chevron, there is not a fillet there. But remember, we're cutting it with a ball-end mill, and even if we weren't cutting it with a ball-end mill, because of going down this hill, it couldn't get an exactly square edge there. So I do have some remaining material, but that's okay because it is a product of using a ball-end mill at that bottom corner. So it looks like my part is good because I didn't have any errors down here in the logger window. Remember, don't want to see anything down there. So that means that this is all looking good. I'm going to turn my stock back on in both windows. Okay, so now I'm ready to feel good about going to lab, and that is how you use Vericut with Fusion. Thanks a lot.